Hello, we're going to do a really fast overview of the Lac Operon and erase mess off the board. So, it really is actually pretty simple. So, you have two kinds of regulation, all right? You have the promoter. You can have a promoter being regulated, so I'm going to call this the promoter, or you can have the repressor being regulated, okay? So, first with the promoter, there is, as an overview, for the lactose operon, you only want to run it when there's lactose around. Why? Because if there's glucose, that's easier to eat. Just eat the glucose. If there's glucose and lactose, you still don't want to waste energy trying to digest lactose. That takes energy. That's expensive. And so you're going to go for the glucose first. Now, if there is only lactose, no glucose, then you actually want to have the Lac Operon. So low glucose is going to make so that you get cyclic AMP, which turns on something called CAP. And then both of these come together to make transcription happen. Okay? That's part one. That's activation of transcription. All right. The other thing you can do is some Lac operons will have a repressor that is bound. And that repressor makes so that you can't ever cause any transcription while it's there. You can think of a repressor like a garage door that is down and when it is bound. And so if you want to go, you need to open the garage door. So get rid of the repressor, get rid of the door. Okay? The repressor is the garage door. And so you go ahead and press the button that gets rid of the garage door, which is known as allolactose. Allo meaning other, as in other form of lactose. And there you go. So you turn on the go button with CAMP. You get rid of the garage door, the off button, with allolactose. And that is literally all that there is. And according to Professor Hilmy, there are multiple Lac operons. So there's this Lac operon, I'll just call it Lac 1, the first one. And then there's another Lac operon, we'll just call this strand Lac 2, that's further down the DNA. And according to Professor Hilmy, you could just have the promoter, or you could just have the repressor, or you could have both on a particular Lac operon. In my undergrad, I learned that both were pretty much always there, but we're both going to look at that a little bit more, because, I mean, otherwise, how would you know that lactose is present if the repressor isn't there to say, hey, lactose isn't here, don't bother making the enzymes to break it down, you know. So, that's pretty much it. I hope that helps. Go ahead.
So I remember her saying something about allolactose being formed by lactose, which means you need galactidase.
So galactosidase, I think. Beta-galactosidase is an enzyme that will make lactose into allolactose, and it is inside the Lac operon. Now, if this thing is turned off, how the heck are you going to get this thing that you need to open the garage door? There is a very small amount of transcription going on, even if the repressor is there. Every now and then the DNA polymerase still gets by. And so you're making a tiny amount of beta-galactosidase, GSase, and that tiny bit will go and act on lactose if lactose ever shows up. And then the lactose is made into allolactose. Allolactose comes and opens the garage door, taking the repressor off. And then you get a ton of transcription.
Okay. Perfect.
All right. I hope that helps, and I'll catch you later.